Welcome back. We're going to do the next 10 problems in the Chapter 7 review of the Stewart Calculus Early Transcendental 7th edition textbook. Okay, we left off on number 11. So we have the integral from 1 to 2 square root of x squared minus 1 over x dx. Okay, so I see a something squared minus something squared. We can do a trig sub. So as always, I set up my triangle. I know that it's something squared minus something squared, so this guy is the hypotenuse, this guy is one of the sides, and the square root is the last side. So I set it up like this. Okay, you can watch my crash course on trig sub video if you're not familiar with this. So I want to substitute everything in this integrand in terms of theta. I need x, I need dx, I need the square root term. How to get x? Secant theta is x over 1. So secant theta is x. dx, we just differentiate secant theta, tangent theta, d theta. Okay? Square root term, which trig function can we use? We can use tangent. Tangent theta is square root term over 1. So that's there. Okay? So we also have to sub our limits of integration. When x is 1, secant theta is 1, so theta is 0. When x is 2, secant theta is 2, so theta is pi over 3. Okay? And then everything else we just substitute with what we found. Square root term is tangent. dx is secant tangent d theta over x, which is secant. Okay? We can simplify this secant, and this secant would cancel. We are left with tangent squared. Okay? Tangent squared we can change to secant squared minus 1. Why do we want to do that? Well, this we can easily find an integral, because integral of secant squared is tangent. Integral of 1 is that's theta. We evaluate from 0 to pi over 3. Tangent pi over 3 is root 3 minus pi over 3 minus, when we plug in the lower bound, we get 0 and 0. Okay? So it's root 3 minus pi over 3. Okay? This one was an easy substitution because integral e to 2x over 1 plus e to 4x dx. Remember your properties of exponents. You can rewrite this as e to the 2x over 1 plus e to 2x squared. Like that. Okay? So we can let u be e to 2x, du would then be 2e to 2x dx. Okay? So when we substitute, we get e to 2x dx, that's just du over 2, so du divided by 2. And then in the bottom, we have 1 plus u squared. This you should recognize as arctan, so half arctan u plus c. And we back substitute half arctan e to 2x plus c. Okay? That one was easy. Hopefully that was easy for you. All right, this one is a little trickier. So you would probably already saw it, but we have integral e to the cube root x dx. So how do we approach this? So I just thought, let's try substituting. Maybe it'll clean things up. U is x to 1/3, or cube root x. I don't like to differentiate this, so I can just cube both sides. So u cubed is x. And then we differentiate from here instead. It's nicer. 3u squared du is dx. Okay, so let's try substituting. It'll be e to the u. What's dx? That's just 3u squared du. And this is integration by parts. Okay, you should be able to recognize that, hopefully. So I just did the Taylor method again. So u is, well, we already have u, so I put y and dz, but it's u and dv, same thing. So for this column, you want it to be something that differentiates to 0, so that's the 3u squared. Okay? And then we differentiate until we get to 0, so differentiate 3u squared, that's 6u. Differentiate that, that's 6. Differentiate that, that's 0. Okay? What's left? E to u. That goes in this column. We integrate just as many times. That's simple. It's just always e to u. We go diagonally and we alternate signs. So plus, minus, plus. Multiply them together. So it'll be 3u squared e to u. That's this diagonal. This diagonal is minus 6u e to the u. That's there. This diagonal is plus 6e to the u. And then plus c. And then before I back substitute, I factored e to the u to make my life easier. I could have factored 3e to the u, but it looks like I didn't. But I factored e to u, so it's this guy. And then we back substitute x's to the, u is x to 1/3. So e x to 1/3 times 3x to the 2/3 minus 6x to 1/3 plus 6 plus c. So this one, substituting, made it into an integration by parts. Okay. This one, x squared plus 2 over x plus 2 dx. Remember in the partial fraction decomposition section, if the degree of the top is bigger than the degree of the bottom, you should do long division, which is what I did over here. Okay? This goes inside, this goes outside. Divisor, dividend, right? So what can we multiply to this to get the degree of this? So we can multiply this guy by x to get x squared, right? So it will be minus x squared plus 2x. We just multiply them together. We subtract these two rows, we get negative 2x, and then we bring down to 2, right? And then we can multiply it by negative 2, so we get minus negative 2x minus 4. So we subtract these two rows. So negative 2x plus 2x is 0, right? And then we have plus 2 plus 4, that's 6. Okay? So we have this remainder and this quotient. The quotient is here. The remainder is 6 over the divisor, x plus 2 dx. Okay? These are all easy to integrate. Power rule here, log here. So x squared over 2 minus 2x plus 6 log x plus 2 plus c. Okay. All right, this one, x minus 1 over x squared plus 2x dx. I tried partial fraction decomposition right away. So we can factor the bottom as x plus 2. That's why I tried partial fraction decomposition, because we have two linear factors. So it's a over x plus b over x plus 2, the simplest case, linear factors that don't repeat. Multiply both sides by the denominator, so we get x minus 1 is equal to a times x plus 2 plus b times x. We plug in easy numbers as always, like x is negative 2, such that this can go away. Then we get negative 2 minus 1, which is negative 3, is negative 2b. b is 3 halves. We plug in x is 0, this would go away, so it would be negative 1 is 2a, a is negative half. Okay, so we can rewrite the integral with our partial fraction. So a is negative half, so negative half times 1 over x, plus 3 halves times 1 over x plus 2. These are both logs, so minus half ln x plus 3 halves ln x plus 2 plus c. Okay, next 16, integral secant to the 6th over tangent squared. Okay, so there's no I don't memorize the rules for integrals with tangents and secants. Okay, so let's just play around. The rules that they want you to memorize, or they teach you about, is if you save a secant squared, is everything even? Because if everything is even, then you can make everything in terms of tangents. So then you can let u be tangent, and then du is that secant squared, okay? Which is the case here. So let's save a secant squared. So secant to the 4th, secant squared over tangent squared. Okay, so as I said, we want to make everything in terms of tangent now, which is doable because everything's even, right? So, so we won't leave this alone though. Secant to the 4th is the same thing as secant squared, and that is squared. Okay, so secant squared is 1 plus tangent squared. So 1 plus tangent squared is secant to the 4th, okay? And then the bottom is already in terms of tangent, so we leave that alone. Now we let u be tangent, du is secant squared. Okay, so our integral becomes 1 plus u squared, quantity squared, du, secant squared d theta, that's du, over u squared. Okay, we can expand the top, 1 plus 2u squared plus u to the 4th, divided by u squared. We divide through by the u squared, so we get 1 over u squared plus 2 plus u squared du. This is just power rule, so it'll be minus 1 over u plus 2u plus u cubed over 3 plus c. And then we back substitute. We let u be tangent, so minus 1 over tangent theta plus 2 tangent theta plus tangent cubed over 3 plus c. Okay. We have this integral x secant x tangent x dx. It's a product of two kind of random things, so I'm thinking integration by parts, okay? And conveniently, we can even let dv be secant x tangent x because we know the integral of that. So dv is secant tangent, as I just said, so v is secant. So u has to be what's left, x, du is dx, okay? uv minus integral v du, that's integration by parts, so uv, x secant x, minus integral of v du, which is secant x dx. Okay, this you should memorize because it's hard to derive. What's the integral of secant? It's ln of secant x plus tangent x. Okay, so this is your final answer right here. Okay. Next, we have this one, x squared plus 8x minus 3 over x cubed plus 3x squared. Again, I see that we can factor the bottom. So we have, if we factor out x squared, it'll be x squared times x plus 3. And we can use the method of partial fraction decomposition again. Here you got to be careful. There's a repeating term, so we have to go a over x plus b over x squared plus c over x plus 3. Okay? Multiply both sides by the denominator. So I flip the 2. A times x plus 3 plus b times x plus 3 plus c times x squared is equal to, top over here, x squared plus 8x minus 3. We plug in easy numbers again, like x is negative 3. This would go away. This would go away. 9c is equal to 9 minus 24 minus 3. So 9 is equal to 9 minus 27. I divide through by the 9. c is 1 minus 3, which is negative 2. We plug in x is 0. Why? Because this would go away and this would go away. So 3b is equal to minus 3. So b is equal to negative 1. Okay? We plug in a last number like x is 1, doesn't matter what number. X is 1 will probably be easy. So we get 4a plus 4b plus c, that's what I got there, is equal to 1 plus 8 minus 3. We know what c and b are, so we can find a. So 4a minus 4, because 4 times negative 1, c is negative 2, so minus 2 is equal to, over here it's 9 minus 3, which is 6. So 4a is equal to 12, a is equal to 3. So now we can rewrite this whole integral as integral of 3 times 1 over x. A is 3. 3 times 1 over x. What's b? Negative 1. So negative 1 times 1 over x squared. What is c? Negative 2. So minus 2 times 1 over x plus 3. All by dx. Okay? Log, power rule, log. So 3 ln x plus 1 over x minus 2 ln of x plus 3 plus c. Okay? Number 19, this one was difficult. Okay? We have this integral x plus 1 over 9x squared plus 6x plus 5. Okay? You can't do a substitution. Well, I don't see one that's doable. Like if u is the bottom, du would be 18x plus 6 dx. Doesn't quite match what's on top. And I probably don't want to do integration by parts. It's not a trig integral. I can't do trig sub here because I don't see like a something squared minus something squared. Maybe if I complete the square, it might end up like that, but probably not because of this x plus 1. Partial fraction decomposition. This bottom is not factorable. Not that I can see. So probably not that. So I'm stuck. What do I do? So remember I earlier hinted to complete the square. Maybe that can help us out. Actually, maybe it won't. Because you have to first factor out this 9 from the bottom before you can complete the square. So I'm stuck. What do I do? You got to try something, right? This is the exam. So what did even I do? So I purposely broke up this 5 into a 1 plus 4. Why did I do that? Well, I want this to be factorable somehow. So I know that if it's 3x plus 1 squared, it'll be 9x squared plus 6x plus 1. Okay? So that's kind of what I did here. So I want to break this up as plus this 5 into 1 plus 4. So that, once again, this guy, 9x squared plus 6x plus 1, that's factorable into 3x plus 1 quantity squared. Okay? Now that I did that, what else can I do? Let me break this fraction up. So into x over the denominator, and then this 1 over the denominator, okay? Why did I want to do that? Well, either way, I made the same substitution, but let's go this one first, okay? If we let u be 3x plus 1, du would be 3dx, okay? So when we substitute, it'll be u squared plus 4 on the bottom, right? How about the top? What's x dx? Well, what's x? We can get x from our definition of u. It'll be u minus 1 over 3, okay? And then dx is just du over 3, okay? So we can change it to 1 over 9, because this 1/3 and this 1/3 makes a 1/9. U minus 1 over u squared plus 4 du. Now we break up the fraction once more. 1/9 integral u over u squared plus 4 minus 1 over u squared plus 4, all by du. Okay? Why did I do that? Well, this, you can do a substitution. So it'll be a log. This is arctan. Okay? So 1/9 log of u squared plus 4 over 2 minus half arctan u over 2. That would be this branch over here, okay? We didn't back substitute yet. We didn't add plus c. We're going to do that all at the end, okay? But this is what I got over here. Maybe there's an easier way. I don't know, but this is what I got, okay? This was an odd problem. So there might be solutions out there, so I'll recommend you look. So this is how I did it, and I got the right answer. This guy, once again, we just made the same substitution. So it became 1/3 du over u squared plus 4. This is just arctan once again. So it'll be 1/3 times half arctan u over 2. Okay, so we're going to add these two answers together and add a plus c, and then back substitute, okay? So this, we can distribute this 1/9, so it'll be 1/18 log of u squared plus 4. Now notice that this is arctan u over 2. This is also arctan u over 2, so we can combine them. This is a minus 1 over 18. This is a sixth. Okay, so add those two scalars and then multiply by arctan u over 2. Okay, now we back substitute, and then we can simplify this fraction to 1/9. Back substitute, u is what? 3x plus 1. So 1 over 18 ln of 3x plus 1 quantity squared plus 4, all in ln, plus 1/9 arctan of 3x plus 1 over 2 plus c. Okay? So this is a complicated problem. All right, so hopefully this was helpful. This one, if you're able to get this, you're probably in good shape. Okay, if you weren't able to get this, I feel like it's still okay. But don't quote me on that. All right, okay. Number 20, and we'll call it part. 20 is integral of tangent to the fifth, secant cubed d theta. This is another integral with tangents and secants, which I don't remember the rules. But maybe if we save, because it's odd, if we save both a tangent, they're both odd. If we save both a tangent and a secant, then they'll be even. So that's what I did here. And when they're even, we can change tangents to secants or secants to tangents. Okay. Well, I want to have a du as secant tangent, so I probably want u as secant then. So let's change this tangent to the fourth to in terms of secant. 1 plus tangent squared is secant squared. So secant squared minus 1 is tangent squared. So secant squared minus 1 quantity squared is tangent to the fourth. Okay, so this guy times secant squared, tangent, secant, d theta. Everything else left the same. We let u be secant, as I said earlier. Du is secant tangent d theta. So then we get u squared minus 1 quantity squared times another u squared times du. We can expand this out. U to the fourth minus 2u squared plus 1 times u squared du. We distribute this u squared to each term. U to the sixth minus 2u to the fourth plus u squared du. Now this is just power rule. U to the 7th over 7th minus 2 over 5 u to the fifth plus a third u cubed plus c. Back substitute u as secant. Secant to the 7th over 7 minus 2 secant to the 5th over 5. I don't know what that is there. Let's just say that's a plus, okay? Plus secant cubed over 3 plus c, and that's your answer, okay? All right, so that's it for this video. Hopefully you found it helpful. If you did, please hit that like button and please subscribe to look out for the next set of problems.